while traveling through this world of woe. Here there's no sickness, toil, or danger in that bright world to which I go. I'm going there to see my Father. I'm going there no more to roam. I'm only going overjoyed. I'm only going over home.
Welcome to Your Brain, a Personal Tour, Seminar 6. Today we talk about some difficult topics, but also about some amazing progress. The goal of the seminar will be to talk not only about some tragic events in the life of many brains, but also to talk about awesome progress that's being made with new tools, with new software, and new understanding of brain operation and recovery. My personal goal is that each seminar participant gains a better understanding of these brain conditions and a better understanding of how each of you can take steps today to minimize negative effects and to advance brain research. The subtitles deals with contributions to this area. They come from many sources. Some are quotidian like dog walking, some are sci-fi like Jedi monkeys. I hope you'll be as fascinated as I was to understand how each of these can contribute to process and to the relief of suffering. Welcome to the seminar. I hope you enjoy it. We'll talk about three areas. The first condition we will discuss is Alzheimer's disease. Alzheimer's disease is a specific case of a more general disorder called senile dementia, and it's the number one fear of Americans in terms of growing older. These diseases place dramatic burdens on family, on friends, and on communities. But recent advances in brain science show hopeful potential, and there is something that each and every one of you can do today to help yourself and to progress the research. Schizophrenia is a dramatic condition of mental illness, most often associated with bizarre behavior and hallucinations, and a favorite topic of horror movies. Significant progress is being made with early detection and cognitive training, and progress here gives hope not only to schizophrenic sufferers, but also many closely related mental health conditions like bipolar disorder. And finally, we'll talk about recovery from trauma. And by that I mean injuries not only to your brain and how to repair them, but also on how your brain can help recover from a devastating trauma to your body. Spectacular progress is being made here, and that means life-changing events for the positive for many people. Now, this is not a downer seminar. Progress is being made in each of these areas. The following clip is from a well-respected neurologist on a topic that's near and dear to each of us, protecting your brain. There's a way that we can do something today that will help us now. Let's take a look.
Back in the day when I was in medical school, we were told that each of us was given a certain number of brain cells, whether it was 100 billion or however many brain cells you were lucky enough to get, and that was pretty much it. That was what you were left with, and every time you drank a beer, you'd lose 30,000 brain cells or whatever the number was for some reason. I don't remember. But that said, the idea that humans don't grow new brain cells is actually now fully demonstrated to be wrong. How exciting it is that we possess the ability to regrow brain cells, a process called neurogenesis, and that we retain this ability throughout our entire lifetimes. So the question you may be wondering is, well, what can I do to increase neurogenesis? I'd like to grow back new brain cells, and here's how to do it. Neurogenesis happens when your brain produces more BDNF. It stands for brain-derived neurotrophic factor. That's sort of the growth hormone for the brain, and we know that you can turn on the amount of BDNF in your brain with at least two things. Number one, physical exercise, specifically of the aerobic type, and number two, by taking into your body a specific omega-3 called DHA. Both of these things stimulate BDNF and therefore lead to increased amounts of BDNF. Let's take a look at how physical exercise makes that happen. Published in 2011 in the Proceedings of the National Academy of Science, a study called Exercise Training Increases the Size of the Hippocampus and Improves Memory. What the researchers looked at was the size of the brain's memory center called the hippocampus, which we know tends to shrink as we age in perfect correlation with our declining memory. And the study looked at 120 adults over a 1-year period. Half the group did some stretching exercise, the other half did some aerobic exercise. They measured the size of the hippocampus with MRI scans. They measured their blood levels of this brain-derived neurotrophic factor, or the brain's growth hormone, and even perhaps most importantly, they measured their memory function at the beginning, at 6 months, and in 1 year. And what they found was that those individuals who did the aerobic exercise in comparison to those who just did stretching had a marked increase in their BDNF levels, meaning more brain growth factor, and in addition, those individuals who did the aerobic part of the story had, quote, substantial improvement in memory function. These results clearly indicate that aerobic exercise is neuroprotective and that starting an exercise regimen later in life is not futile for either enhancing cognition or augmenting brain volume. There is no other prescription. There is nothing that can be written on a prescription pad, although I tend to write that on a prescription pad, please exercise. There's nothing you can get at the pharmacy that will improve your memory and protect your brain. And now we know that the simple act of aerobic exercise will not only improve memory function, but actually allows you to regrow new cells in your brain's memory center. That's pretty powerful information. I'm Dr. David Perlmutter.
The DHA Dr. Perlmutter was talking about can be bought in a variety of forms in your local supermarket. You can go to a specialty vitamin store, but it's not necessary. It's typically found either in a pure form, and it'll be labeled DHA on the bottle, or more commonly, it'll come as fish oil. This fish oil will have both omega-3 EPA and DHA. But recall, it's the DHA that has been found to be clinically impactful. There is nothing that I found in my readings that said any particular kind of fish oil is better than another. So it doesn't need to be wild-caught salmon. These can be factory-farmed fish for all I see in the literature. And in fact, most scientific studies these days use DHA that has been obtained from algae. So you do not have to pay extremely high prices in order to obtain this chemical to help protect your memory. I read the study Dr. Perlmutter referred to, and I found some very interesting facts. First, the average age of the study participant was 65 years of age. Second, the aerobic exercise they used was brisk walking. Now, this walking had to be aerobic, so that meant getting your heart rate up to 60, 70, 75% of your maximum heart rate calibrated by age. So this is a heart rate chart where I've placed a red dot on the target range for the study participants. And at this level, this is the kind of exercise that has now been shown to be neuroprotective. It helps you grow new brain cells. It helps you improve your memory. So, want to grow more brain cells? Want to increase your memory? Well, then exercise. No matter how late in life, most can do this today. Walking is a great way to start, especially with a dog. If mobility is an issue, then talk with your doctor about some other kind of aerobic exercise plan. And one final point. We'll see later in the seminar that social factors help as well. So if you're going to walk, why not do it with a friend? People are almost as good as dogs, or a cat, or a small pig, whatever. Just get out and walk. You and your brain will be glad you did. Let's focus in more detail now on Alzheimer's disease, or AD. Not only is AD the number one fear of many growing old, it also places significant burden on society, on family, and on other people. Virtually every minute, someone in the U.S. is diagnosed with AD. Millions of caregivers devote billions of hours of care. The net result being billions of dollars in cost to the nation and inestimable cost to families. In fact, some families will go hungry in order to care for a loved one with AD. As devastating as AD is here in the U.S., a high-income country, the projected effects of AD is expected to be much worse in the low to middle-income countries around the world. Some, perhaps half, of this increase is due to longer lifespans in the global population. In other words, improvement in the overall quality of life, which leads to longer lifespans, have a correlated effect of more people being diagnosed with AD, since they're living longer than their parents or grandparents. But there's another factor in operation here, and these are factors associated with lifestyle and environment. This slide presents a host of factors for either decreasing AD risk, green arrows, or increasing AD risk, red arrows, in both humans and rodents. We include rodents, and that means rats or mice, since they're the most common animal model in which we study AD in the lab. The good news here is that there's lots of green arrows on the slide. The bad news is that there are many red arrows still on the slide. And the red arrows tend to be associated with factors that we find in poorer countries. For example, pesticides, pollution, metal contamination, and poor nutrition. We'll talk about cognitive simulation in a moment, but I do want to draw your attention to the green arrow associated with physical activity. You'll also see the impact of good nutrition with green arrows, and correspondingly, red arrows with bad nutrition. So this is just not a personal problem for people, but a global problem for societies, and nations will have to bind together and work as a whole to address some of these risk factors. So where are we relative to AD in 2016? We'll look at 4 areas. The first is current treatment and trials. Unfortunately, the news here is not very good. Second, we'll see how studies with religious orders have helped us understand that building cognitive reserves of brain power can really help lower the risk of the disease. Third, we'll look at new ways of detecting AD early in life. The better we can do this, the better we can apply new approaches with promise. And fourth, we'll look at new treatments in the pipeline and what they can mean to the treatment of this disease for us or for our children and grandchildren. Unfortunately, by the time AD is diagnosed, it can almost be too late. Treatment options today are very limited once a fully confirmed diagnosis is rendered. And that's because the disease is likely present decades prior to diagnosis. At a typical age of diagnosis, shown on the left, the brain has changed dramatically, as shown on the right. The thickness of neurons in the cortex has thinned considerably. The white matter of the brain, that is, the connections of the various parts of the brain, are atrophied. The brain has just overall shrunk. 2 changes in particular stand out. The first is amyloid plaques in the white matter of the brain. These are now understood to form an accumulation of a specific amino acid, A-beta-42. This amino acid is naturally produced in your brain, but in AD, A-beta-42 is not cleared sufficiently and it builds up, leading to plaque. Inside of the neurons, the cells of the brain, there are tangles in the basic cellular machinery. These tangles interfere with normal neuron operation and hence result in loss of cognitive ability. The tangles are caused by the presence of a misfolded, naturally occurring protein called the tau protein. This misfolding seems to be caused by the accumulation of A-beta-42 by a cellular mechanism unknown to date. So, not too much good news on the current treatment front, but nuns to the rescue. A particularly difficult aspect of any scientific study of AD is the length of time over which the disease developed. Decades. How does one get a control group to compare changes of lifestyle, etc.? Well, religious orders offer a fantastic opportunity in this regard. A group of nuns, for example, live a very similar lifestyle over many, many years, decades often. And one group of nuns in particular at Notre Dame contributed greatly in our understanding that exercising your brain and building what is called a cognitive reserve dramatically lowers your risk for AD. The world is a better place due to these nuns, not only because of their charity, but because of their contributions to science. The initial finding was that nuns who expressed in their daily journals a high density of ideas, in other words, they had a rich writing style or a learned writing style, were significantly lower in risk for AD. This caused a flurry of studies to examine other aspects of lower AD risk, and the results were interesting. For example, bilinguals rarely get AD. Likewise, people who play musical instruments, or read a lot, or play novel games a lot. These results focused attention on a brain quality termed cognitive reserve, a loose quality perhaps similar to muscle mass that conferred protective ability for your brain to ward off AD. Finally, it was noted that the earlier such reserves were generated, the better, but starting even late in life had positive effects. The key finding coming out of AD research today is that we need to detect it as soon as possible. The sooner someone understands their risk, the sooner treatment and building even more cognitive reserve can begin. It turns out there's some very promising developments here. First, there are clear genetic markers for elevated risk of AD. The best example is a gene variant called APOE4. Inheritance of this gene variant is associated with significantly elevated risk, as shown on the left side of this slide. Common genetic tests like 23andMe test for this gene variant. This testing can be done prior to conception and at birth, well before any symptoms appear, and hopefully before any brain changes. Later in life, we can test for the presence of an imbalance of the critical amino acid A-beta-42 in cerebrospinal fluid. This is done by puncturing the spinal cord in the lower back and withdrawing some fluid. Several years ago, this was deemed a risky procedure. However, recent experience in Europe indicates that the procedure is low risk and can easily be tolerated. Finally, tremendous progress has been made in developing compounds that pass the blood-brain barrier and highlight brains that are at high risk of AD, but prior to symptoms being presented. All of these procedures mean that today it is much more likely that we can identify a person at risk for AD decades before the symptoms present, and close in time to many changes in the brain that precede the expression of the disease. When we find such a person, then intensive effort to build cognitive reserve can be focused. Of course, it never hurts to build this for everyone. If we detect brain degenerations associated with AD, is there anything on the horizon that looks like it could repair the damage? The answer in this case is a qualified yes, but it's early in the research cycle and the sample sizes are small. There are clear grounds for hope, but not grounds to pop champagne corks just yet. The therapies focus on two main themes. Addition of neural stem cells aims at increasing the brain's natural ability to generate new cells. Recall Dr. Perlmutter's video at the start of this seminar. The cells can come from the patient or someone else. Early research is positive on the potential positive effects, but cost is an issue, and the development of cancers is an issue. The main point here is that there's an active research program that's receiving major focus and funding. Perhaps not for us in this seminar, but for our grandchildren. This will be an available therapy to help repair the damage from AD. The second set of therapies involve repetitive stimulation of the target areas of the brain using transcranial stimulation. The great advantage here is that surgery to open the skull is not required. Magnetic fields or direct currents are applied to targeted areas, and this has had the effect of stimulating cell growth and recovery of function in early trials. Given that the main symptoms of AD are memory loss and confusion, Both therapies are targeted to major areas of the brain that support this function. Any guesses? Well, it turns out the hippocampus, which we saw in Seminar 3, and the prefrontal cortex, which we covered in both Seminars 3 and Seminars 4, are the target for both of these therapies. I will bet the majority of the people in this seminar have personally interacted with this disease, in your family, with your parents, with your friends. And there is something that each and every one of you can do to help those people. You can support advanced research on the hallmarks of AD by playing a video game. Surprised? Don't be. This is happening more and more in science, and it is an all too rare societal benefit for those all too common mobile smartphones. Let's take a look and see why I would like each of you to download this game and play it. I have.
No one's ever survived dementia. There are no treatments that tackle the disease itself. We need to understand more about the condition. We need to understand how we can treat this disease. We know that research holds the key, and for the research to be able to take place, we need data which doesn't exist.
So scientists' lack of data is slowing down research. We thought that maybe we could look at this problem from a different angle.
One of the first signs of dementia is that people start losing their ability to find their way around.
What makes this project really unique is the combination of cutting-edge science combined with a games design company to reach out to hundreds of thousands of people in an experiment that we couldn't do in a lab.
The game is split up into 5 different themed areas. You're a sea explorer and you're recovering memories for your father. You're going on the journey that he went on and you're doing it in his boat. And as you move around, your position gets relayed back to the scientists and they can see it like a heat map. And that data is used to try and understand on a mass scale how people are navigating around these different mazes.
But actually all that data, every little movement they make, every choice they make in that game, it's going to help our research. And the more we can find out about how people find their way around, the better we can understand the problems people might get in dementia.
It's a total reinvention of the way this kind of research data is collected, stored and accessed. It's not just engaging, it's also scientifically valid and above all secure.
If we can get hundreds of thousands of people to share their time and participate, we can answer questions we could never have dreamed of answering before.
By playing this game, they're helping being part of the solution. They're helping us be that little bit nearer to finding those treatments and understanding how we can better diagnose dementia.
I'm thrilled to report that there's new news on this front, and this news is highly topical. It was first reported on the 2nd of November of 2016, and the popular press headline was Alzheimer's treatment within reach after a successful drug trial. The scientific paper is listed below. It deals with a drug called varubisisat, which is an oral pill produced by Merck. To make a long story short, this pill appears to halt the formation of new plaque. This is an outstanding result. What is left to be determined is whether that by halting the formation of new plaque, we see a recovery or at least a cessation of mental decline as the disease progresses. Phase 3 test reports will give us an indication of this. And if the mental decline is halted or hopefully improved, then this drug will be rushed to market. The advantage of being an oral tablet is significant because then the cost per treatment can be much lower than another drug that is very promising in the pipeline called Biogen. Biogen is a monoclonal antibody. It has been tested and published in August of 2016, and the results were very, very promising. However, the cost of Biogen will probably be significantly more than this drug. Nature reported on Biogen, which goes under the legal name of aducanumab. I'm not very good at drug names here. And the exciting thing about this drug is that when you do brain scans of people who have Alzheimer's disease, and we show those brain scans on the right, and we compare a baseline with then a treatment of this drug over the course of a year, and here red indicates plaque buildup. So red in the diagrams on the right are related to the expression of Alzheimer's disease. What we see with this particular drug is a dramatic reversal of plaques. The plaques seem to be cleared within the brain. That is associated with a recovery of mental function. And so these are outstanding results, both in terms of the halt of the progression of this disease, as well as the potential recovery of mental function from 2 new drugs. This is outstanding progress and thrilling progress, and more will be reported in the scientific press over the next few years. I would definitely keep an eye out for these drugs if you have a loved one or a family member that is suffering from this debilitating disease. And remember, not only can each of you help progress the scientific effort, each of you can lower your risk. While taking a genomic profile, while evaluating your cerebrospinal fluid, or playing a video for the good of science, don't forget to walk your dog. If there's any magic bullet here, exercise is it. Do it with friends, doesn't have to be a dog. Do it to get your heart rate up. Do it to keep your memories. Time now for Homer to weigh in for the section summary. And to put it bluntly, Homer is worried. For those of you who watch The Simpsons, you know that Homer's lifestyle is not exactly conducive to good nutrition, aerobic exercise, and building cognitive reserve. So Homer knows he is now at high risk for AD. But without rationalizing, Homer can truthfully state that there are positive developments that show great promise for all of us, even him. Each of us can do something as of today to help lower our risks, even Homer. And each of us can start doing something today to help progress research. And those are very, very good things. I will never forget the first time I saw Jack Nicholson break through a door in the movie The Shining and say, "Here's Johnny." It scared the bloody daylights out of me. Many of you may have had the same reaction to the movie and to your perceptions of the mental health disease of schizophrenia, which Jack portrayed. The disorder is a complex one. It affects about 3 million Americans, about 1% of the population. The social costs are high. Someone with untreated schizophrenia is 37 times more likely to commit suicide than an average American. The life of an individual who suffers from this condition can be a living hell, as seen from the self-expressed art, one of which is shown in the middle panel. Feelings of terror, persecution, confusion are common. Cruel acts have been associated with the disease. And up until recently, the standard diagnosis was one of exorcism from society. That means full commitment to a mental institution for the remainder of the life of the sufferer. But with better understanding of the brain, new hope is dawning in this area, and we'll cover that next. As bizarre as the symptoms can be in this disease, or as cruel in the case of Charles Manson, human culture has benefited from individuals with schizophrenia. Notably from the theories of John Nash, a famous mathematician portrayed in the film A Beautiful Mind. Nash won the Nobel for his contributions and suffered the condition until his death in 2015. Vincent van Gogh is believed to suffer from the condition as well. His art shows clear similarities to typical schizophrenic art, and his symptoms map well with the typical ones for the disease. Vivien Leigh, the unforgettable Scarlet of Gone with the Wind, was diagnosed with the condition as well. It would serve society well if we could illuminate the sources of this condition, detect them early, and then launch interventions. Significant research is in progress along these lines, and we'll look at them now. A key observation is that schizophrenia develops along a path that in many ways is similar to Alzheimer's disease. A combination of factors, some hereditary and some environmental, give rise to a set of neural vulnerabilities that a high-stress event later in life, most typically in adolescence, seems to cause a flare-up of behaviors that signal a full onset of psychosis. And much like AD, if we can forge tools to uncover markers and indicators for risk, then perhaps we can intervene with treatment before the onset of psychosis and retain the possibility of the subject's contribution to society and their ability to live a full and happy life. So let's take a look and see where we are on this search in 2016. The first point to realize is that schizophrenia is a vast collection of symptoms, surely arising from several affected brain regions and systems. Each person experiencing the disease will show a different constellation of symptoms. There are, however, discernible categories and symptoms. The most fluid are hallucinations and delusions, along with a general flattening of affect. Many people suffering schizophrenia are veritable Eeyores from Winnie the Pooh. But just as severe are cognitive and social deficits, which are shown on this slide. Of note is that drugs developed 60 years ago have consistently proved to minimize the positive and negative symptoms. But no new compounds over the last 60 years have been shown to have proven efficacy on any other constellation of symptoms. Clearly, new approaches are needed, and they're beginning to be developed as we speak. Schizophrenic patients show a constellation of deficits that relate to the primate brain capabilities we studied in Seminar 4, as shown on this slide. Specifically, deficits in valuation of future outcomes, bizarre categorizations, very great difficulty in tending to steps towards a goal several steps away, especially when one of those steps take them away from the goal rather than progressing towards the goal, and deficits in strategies to deal with success and failure. As we saw in Seminar 4, these capabilities relate to the dramatic evolution of specific brain areas, the prefrontal cortex for executive functions and strategy, and the temporal lobe for abstract categories. Thus, a schizophrenic patient is often frustrated by situations requiring task planning or goal focus. These frustrations generally drive emotional states which are at best unhelpful for the task at hand. These results then yield specific areas of the brain to target for analysis, treatment, and repair. Another key observation is that schizophrenic patients now show clear deficits in theory of mind capabilities. We studied theory of mind networks in Seminar 5, and recall that theory of mind is considered to be a unique human trait. It turns out that schizophrenic patients view triangle tests very differently than normal subjects. Recall the triangle animation that we saw in Seminar 5? A cute little child triangle was scared to venture out into the big world beyond his box, and his mother triangle coaxed it out and then played with it. Well, schizophrenic patients are unlikely to detect and attribute such mental states to cute triangles. They posit different and inappropriate states or no states at all. And more informing, schizophrenic patients overinterpret the mental states of triangles who are moving in random patterns. Normal subjects mentalize no mental states to such triangles, but schizophrenic patients do. One might remark, "Oh, that one is out to get the other one." In addition, schizophrenic patients show reduced activation of the theory of mind network in standard test. We studied these networks as well in Seminar 5. The theory of mind alterations means that a schizophrenic patient would be woefully challenged in negotiating a social environment. So, at this point, we know that we can target treatment to two major brain systems, the primate brain system and the theory of mind system. But how do we find out who to target early in life? Schizophrenia is a highly heritable disease. If one identical twin expresses the condition, there's greater than a 50% chance that the other twin will express the condition. If you are related to a schizophrenic sufferer, you are at risk correlated to your degree that you share genes. Much of modern research now focuses on what are the specific genes that confer schizophrenic risk. The search highlights the role of what are called SNPs, or single nucleotide polymorphisms, SNP for short. This is a difference in a single position in the genetic code for a single gene between two individuals. In this case, one with schizophrenia and one without. This research has been greatly accelerated by technology from the computer industry. There are now actually chips that process biological information, called DNA chips, as we see here on the slide. The DNA chip allows the screening of the entire genome of a patient to be screened cost effectively. Screening events of note cause small dots of light to emanate from the chip, as in the background of this diagram. You then get a computer to count and analyze the dots of light, and this tells you a lot about the genes under study. To scan for biomarkers for schizophrenia, we take a population of schizophrenics, shown here, say in blue, and compare them with normal non-schizophrenic controls, shown here in red, and then we map the differences with DNA chips. What we get looks like this. This shows about 100 locations, 108 to be exact, that are related to risk of schizophrenia. The height of the little bars relate to the risk. Everything above the line is considered to be related significantly to the risk of schizophrenia. So voila, we can use this chip technology to scan the genomes of people at risk for schizophrenia and use the analysis to detect who needs special and early treatment for the disease. But what kind of treatment? Let's look at that next. Believe it or not, the treatment looks a lot like playing video games. Recall that we have two areas of the brain to focus on. The primate capabilities area, that, for example, the prefrontal cortex and the temporal lobe, and the theory of mind network. We target the prefrontal areas with training on executive function. That means focusing on a goal several steps away, even if a step takes you farther away from the goal in an intermediate step, or developing strategies, or exercising working memory to recall what happened 2 steps back. There is software available for doing this, and it's designed by neuropsychologists specifically for this type of condition. We target the theory of mind network with training on how to interpret facial expressions of others, as shown on the right. The exercises here get the subject to reflect on the perspective of some other and to correctly interpret the social cues about emotion and intent, so no more paranoid triangles. This is an exciting area of research and therapy. The tools are cost-effective and engaging. The promise is real. There can be conflicts of interest. Some of the neuropsychologists own the startups making the games, so some amount of care is needed in interpreting the results. But on balance, this is a very, very promising area of progress for a very, very devastating mental condition. There have also been attempts to treat schizophrenia with transcranial direct current stimulation of both the theory of mind network and the frontal cortex. These are promising tools to improve neural function, often used in conjunction with the video game training we saw on the previous slide. The advantage here is cost for this treatment. It is quite reasonable. The machine that is sitting on the table is in the thousands of dollars range, far less than an MRI machine or an operating room intervention. These are early days for such trials, but the indications are good. Used as in conjunction with the training shown on the previous slide, it means that real durable benefit is potentially available for the treatment of schizophrenia. So not to belabor the point, but I do want to point out that exercise, aerobic exercise, has also been found to be effective at minimizing some of the symptoms of schizophrenia, and I did want to quickly point that out. So for this section, Homer's points are pretty straightforward. The first is, when the advanced parts of our brain, which are very, very complex, when they go funny, there's complex mental conditions that arise. Schizophrenia is a good example of this. But new technology allows early detection, and with early detection, just like in Alzheimer's disease, we can apply early treatment. Early treatment models of cognitive training and perhaps cortical stimulation offer cost-effective treatment with promise. But we are early days here. The testing has only been just begun, but the future is looking increasingly brighter by the day. In this last section of the seminar, we'll cover two major items. First, what can be done to help your brain when your brain, is injured? In particular, we'll look at stroke. And second, how your brain can help your body when your body is injured. In both areas, there's exciting developments in progress, so let's take a look at them now. A stroke is an event that harms an area of your brain. There's two types. By far the most common is termed ischemic. It's a condition where something plugs a blood vessel in your brain and the affected neurons are deprived of blood flow. Brain neurons are notoriously hungry. They consume over 25% of your caloric intake each day, and they quickly die if blood flow is cut off. The second type of stroke is where a vessel wall breaks at a point of weakness. This causes an interruption of blood flow as well as swelling of the brain. This is a double whammy since neurons are starved of blood and the brain overall gets increased pressure since the skull cavity is fixed in volume. In the U.S., stroke is the prime cause of long-term disability, and it results in over $40 billion of cost to the economy on an annual basis. Stroke is a global problem as well, where lifestyle is a key contributing factor. Steps to prevent are easily found on the internet, and most probably with your annual discussion with your doctor. Today, I want to talk about new treatments for when a stroke has already occurred. New treatments are needed in the case of stroke because current treatments are not satisfactory on many levels. Since stroke involves the death of brain neurons, one hope was that stem cells or associated factors would be a magic bullet in treatment. As we see on the left, there are several sources of stem cells and their factors. But unfortunately, out of over 1,000 substances tested over the last decade, only one is credited as a therapeutic treatment, and it must be administered within 4.5 hours of stroke onset, which is almost impossible to achieve. A second line of investigation was early intervention immediately following stroke. In other words, get the patient up and moving immediately after stroke or admission to the hospital. As it turns out, this has no therapeutic effect, as shown on the right. Continuing to look at the right, note that over time, there is recovery of function, but it takes time, lots of time. 20 to 30 days is often the case, as shown in the recovery of walking in this section on the right. An emerging consensus then is to, quote, work with what is left. That means help the brain reorganize as best it can using good nutrition, exercise, and physical therapy, but also explore new technologies to help the remaining areas of the brain take over old function, either directly or indirectly. Some of these therapies use widely available consumer technology. Just like we've seen earlier in this seminar, such technology can be a really great help. Here is an example of a person using virtual reality training to augment physical therapy. It has been shown to be cost-effective and usable in nursing homes and assisted living centers. It's been quite helpful in the recovery of movement, say walking, and it has also turned out to be fun for the patients. Who would have guessed? So if you walk into an assisted living center in the near future and you see a lady like this, don't laugh. She's not just being hip, she's being healthy. Many of these new technologies originated in a set of experiments done in 2008 in the laboratory of Dr. Andrew Schwartz at the University of Pittsburgh. This research was the first to show a monkey's brain directly controlling, with a fine level of detail, a robotic hand. The monkey is only connected to the robotic arm via a set of electrodes in his brain. A computer reads the signal and then causes the arm to move. The monkey attempts to do a series of tasks and then is rewarded with juice coming out of this copper tube. In early videos, the monkey resembled Yoda raising the starship on Star Wars, so the name Jedi Monkey stuck to the video and to the monkey in the research community. From the vantage point of 2016, the experiments of 2008 seem quaint, kind of like your first mobile phone. The old stuff was big, slow, and expensive. But the Jedi Monkey showed what could be done. What then remained was to make it small, cheap, and vastly more functional, just like the phone in your pocket or purse today. In 2016, brain electrodes are made in arrays. They are tiny, tiny, tiny. They have embedded material to sharpen the resolution of detected brain activity. But the real breakthrough progress has been in the hand and arms of the robot. Today, there are robot hands that have the full 30 degrees of freedom of the hand on your body. These robotic hands are revolutionary in the terms of capability, but they still need to be controlled by a brain, and that's where the current challenge is located, and that's where the current focus of progress is in research. The electrodes in the Jedi Monkey were in a part of the brain that controlled detailed movements. So not only were the robotic hands big and clumsy, the Jedi Monkey had to think hard about controlling each and every small movement. But wait a minute, we know about motor program cells. We saw them in Seminar 1. They encode the intended movement. Remember, a good example was the cell that encoded bring food to mouth. Well, we can use this new knowledge of brain control and help people control robotic hands. To do this, let's watch a clip about Eric Sorto. Eric is 32. He had an accident in 2005 that severed his spinal cord at C3 and 4. See the diagram on the left part of the slide. This left Eric without the use of either his hands or his legs. There's no audio in this clip, so we'll see some prompts and I'll comment as we see the film. Eric is controlling this robotic arm. The assistant is holding the handle, but Eric's thoughts are squeezing this control. By squeezing, Eric, in essence, operates a blender, and that allows him to make a smoothie. But there's more important things Eric wants to do. He wants to be a regular guy. And that means lift a beer to his lips. These movements are smooth, much smoother than the Jedi Monkey, because we've targeted a different area of the brain. Again, these are proof of concepts, but they show what these new kinds of robotic arms and hands can do when coupled with advanced understanding of brain circuitry. And that allows people like Eric, people with no previous use of their arms or legs, to be like a real guy and share a beer with one of the guys. And there's nothing that makes Eric smile more than that. Now, the area of the brain that is being used here is the posterior parietal cortex. We studied this in previous seminars, and it shows you how understanding of advanced brain circuitry coupled with the technology innovations that are coming in the form of prosthesis can bring life-changing events to people like Eric. Follow-on research by different technology labs and researchers focus on improving the technology so that surgery is not required to implant the electrodes. This would eliminate a major item of cost and risk compared to Eric's example we just saw. A sample headset is shown on the left. A sample use is shown on the right, the control of a wheelchair. The wheelchair would be controlled by thought, so it would be of use to people who have lost complete use of their limbs. A different theme of research enabled by the Jedi monkey deals with a device called an exoskeleton. This device can be used by people with lumbar or thoracic spine lesions, people who still have the use of their arms but not their legs. Here we see a volunteer who has lost the capacity to walk again. He has an EEG skull cap on to enable a computer to read again his intentions and then provide direction to an exoskeleton that allows his legs to move, to have him stand upright, and to walk again. No surgery is required. Software is then used to enable the training of this robotic device, and the eyeglasses he has on helps the computer understand where he is looking. This person is not blind. This is a European project of great hope. It doesn't involve surgery. It is software to enable the reading of intentions through an EEG cap, and it offers dramatic hope for people who still have use of their arms to regain the use of their legs. Sometimes it seems that research is following movie plot lines. In this instance, from Star Wars to James Cameron Avatar. In this set of experiments, one monkey is controlling the movement of another monkey's body, and it is doing so on the basis of its thought. So the monkey shown on the top of this slide, who has brain implants, can be considered the Jedi, and the monkey shown on the bottom, whose bodily movements are being controlled by the monkey on top, could be considered the Avatar. This type of experiment allows us to better understand brain control either of spinal cord movement pattern generators or individual muscles by themselves. The reason you would use this kind of scenario is that there is no confusion of muscle commands coming out of the thought process of the Jedi on the top being mixed with proprioceptive feedback from his own muscles moving. Here, the Jedi on top is directly causing movement of the Avatar on the bottom when the Avatar, the monkey on the bottom, has been functionally sedated and has no voluntary movement. This is a very unusual yet very exciting mechanism to further refine our understanding of brain control of movement and muscle. Now we go from the movies to TV. Anyone remember The Bionic Man? Well, this is slightly different. Here we have a situation where we want to use the contraction of muscles rather than thought to control a robot arm or hand. The reason we want to do this is that picking up the signals that contract a muscle are far easier and cheaper than opening up the skull to implant electrodes. And it's far more reliable than picking up EEG signals with a headset. In this example, we'll monitor the muscles that contract when someone thinks about closing the hand. We would then have a reliable signal to control a robot hand to close. That's a great idea, but there's often one problem. The muscle we want to monitor could be too weak or not there, as in the limb was amputated. So what we do is we reimplant the nerve that controls the muscle, that controls the closing of the hand, into somewhere else. Thus, when the patient thinks about closing his hand, some other muscle will move. But that's okay. We can still use it as a signal to control the robot hand, which is what we wanted to do in the first place. It sounds a bit complicated, but when you see it in action, it's inspiring. The person in this clip lost both his arms over 10 years ago in an electrical accident. Using the advancements of the Jedi Monkey and other robotic innovations, the people at Johns Hopkins have produced a bionic set of arms that will give this person the ability to reach and hold again. As part of the process, the scientists moved nerves that control his arms and hands to his chest. That reinnervation then allowed the vest holding the robot arms to pick up signals for control. The person thinks about moving his arms and picking things up, and the arms react. Let's see the story. Closed captioning was not available, so only audio is available in the clip.
Arriving at APL this past summer to participate in an on-site field study with the Modular Prosthetic Limb, MPL, Les Baugh and his girlfriend were excited about the possibilities. Accompanying them is Dr. Albert Chi, who, as part of the interdisciplinary team from the Johns Hopkins Hospital, performed the targeted reinnervation surgery necessary for today's visit.
I went into the surgery knowing that he was going to move nerves in my chest. I remember when I first came out from under it, the pain I'd never had. I don't even remember the original being that much excruciating pain, but I imagine part of that my mind blocked out anyway.
Les had lost both limbs in a freak electrical accident over 40 years ago and is excited to become the first shoulder-level amputee to have the MPL fully and wirelessly integrated into his body.
Get started with really intensive training with our pattern recognition system. And what the pattern recognition system is a advanced algorithm that really looks at high-density electrode arrays on the chest muscles, which we've reinnervated, that looks at the almost signature symphony of muscle activity information, and we take that information and translate that to actual movements within a prosthetic.
Let's go ahead and see what we have.
On this day, Les is being fitted for his socket, which is sort of a body brace that makes the neural connections with the reinnervated nerves, as well as supports the prosthetic limbs.
The first cast they did on me for the test socket was all done with electronics. They took like a scanner, and just started walking around my body, and they just painted it on the screen, and boom, they sent it off, and I get out here and it fits. This guy says, no, I can't feel every little dimple and divot that I want to feel. He says, I want to do it with plastic. Great. And this old school is working out so much better than the modern.
While the socket got its finishing touches, the team took the next step and had Les work with the virtual reality system that mimics the actual prosthetic arms.
Relax. Let's do some elbow up. Good. Relax.
A couple days later, the socket was back, and the arms were attached. Les and the team were about to make history.
Once the training sessions were complete and they released me and let me be the computer, basically, to control that arm, I just go into a whole different world.
I think we're just getting started at this point. It's like the early days of the internet. There's just a tremendous amount of potential ahead of us, and we've just started down this road, and I think the next 5-10 years are going to bring some really phenomenal advancements.
Other milestones reached by the team were, this was the first time the MPLs were operated by a shoulder-level amputee at the full 3 degrees of freedom and with over 30 total degrees of motion on both sides with complete intuitive thought-based control.
He has access to all of the different degrees of motion, shoulder, elbow, wrist, hand, but he still needs to select which one he wants to use. So he needs to position the shoulder, then the elbow, then the wrist, then the hand separately and rest in between.
Maybe I'll be able to, for once, be able to put change in a pop machine and get the pop out of it. Simple things like that that most people never think of. And it's re-available to me.
What we'd really like to be able to do is send him home with a couple of limbs so that, you know, he can use them in his everyday life. And what this has showed us is that that's really possible.
All of us on this RP 2009 team, regardless of the type of patient we're fitting, are committed to making every effort to see that this ultimately reaches the end user in a way that they can actually utilize it.
That's awesome.
It's not just the accomplishment, but the opening of frontiers and realizing that there's so much more to learn.
This unique opportunity of interfacing with the end user, utilizing our technology, provides valuable feedback to the team. Feedback that will assist this DARPA-developed technology in helping wounded warriors and others to regain the 27 degrees of freedom possessed by the human arm.
After that, Homer is uncharacteristically speechless. Basically, Homer thinks this is awesome. I hope you are as thrilled about progress in this section as I was when I first saw it. Expect that over the next decade, amazing progress will be made. These advancements will not only bring grace to our generation, but will surely bring many miracles to our grandchildren. This concludes the seminar series. I hope you've enjoyed it as much as I have enjoyed making this seminar series. I thought it would be beneficial to kind of give you my 3 thoughts to take away, the top 3 ideas that I would say distill the essence of this seminar. I call them the 3 C's. The first is to conserve your brain. Your brain is a marvel of the universe, so take care of it. Do what your mother and father told you to do, sit up straight, eat your vegetables, and walk the dog, or your cat, or your pet iguana, or tortoise, or whatever. And do it with a friend if possible. The social stimulation, the aerobic exercise will do you good. The second is to celebrate the progress in the understanding of an organ that's more complex than the galaxies above our head. And also celebrate the progress that we have seen in relieving human suffering via neurotherapeutics. If you can, take a neuropsychologist out for a lunch or drink someday. And then finally, consider the fact that your brain and all other brains on this planet have unconscious systems that encode evolutionary skills that were essential for our emergence. Perhaps they're unhelpful in today's society, but use your advanced brain systems to deliberate and construct actions that can moderate them as appropriate in today's society. The audition of players for a symphony orchestra is a good example. To conclude, I have a short film of credits to thank people who were so helpful in the construction of this seminar, and a few pictures of Austin, Texas, my home. This is Steve Saltwick.
Feel like cutting the rug have a Texan in the band.